Okay, welcome to another one of these weird talk things, I guess. They're quite easy for me to do research on and churn out straight, from my brain to the presentation, so I can make them quite quickly, which means I'm probably going to be making quite a few of them. But let's talk about structured programming. Um, I'm thinking of doing some stuff with like Pascal, but that'll be another video. But let's see what structured programming was about, what it is about, what makes it interesting. So this is a truncated talk. My first reference is a 1.5 hour talk that I highly recommend if you're more interested in this. I have to go kind of quickly. I'm trying to hit like a 6-7 minute target mark. So all right, here is a normal function, a normal C function, right? Our good friend, a while loop. This will return 10 or so, and pretty simple. So this is how we would do it structurally, right? This is how we're used to doing it. We indent here, we return whatever, right? Nothing too interesting. How would this look like if we didn't do it in a structured method? Well, we can do it if go to, right? Where this would be pretty much equivalent. You go to a label. I mean, the label might be whatever you want. Some languages it would just be a number, and then you have your integer and whatever, right? This will do the same thing. Now, what's the problem here, right? I mean, obviously this might be a little hard for you to read if you're not used to go-tos, but you might get used to it, right? It's not You've been seeing structured programming code all your life. You could probably adapt to reading something like this, but uh, you know, but here's the thing. If we can start seeing things. I'm trying to keep the examples minimal, but we can start seeing where the problems could come in by adding one extra method call, right? And by adding one extra method call, when we take a look at how this one would look, we see that a something in the loop is at the same indentation level as something outside the loop, right? So something outside the loop, same indentation level as something inside the loop. And you could indent everything, but even this idea of indentation was something that was very much associated with the structured programming kind of revolution, where even stuff like inside this if statement would be unindented, even inside this function would be unindented. I didn't do that for clarity, but you have to understand that even these concepts of writing like an outline were ones that didn't really exist before 1960, and even in the 1960s weren't really common or as common. Okay, so we can sort of see, you know, why we've moved towards structured programming and why it could be useful. Uh, so obviously this way of reading isn't intuitive. It's not how people are used to reading. It introduces quite a lot of cognitive overhead and what the talk would call short circuiting in your brain. So you might be asking like, what language doesn't have loops? Well, Fortran, the original Lisp assembly. There might be some assemblers with loops. Don't quote me on that, but you know, older languages. One of the quotes is, "The sooner we can forget that Fortran has ever existed, the better." Later on, it wastes our brain power, is too risky, and therefore too expensive to use. Um, but yeah, the example is a bit contrived. Check the talk for a more thorough examination. And actually, the rest of this presentation is largely adapted from that same talk, so I highly recommend you go look at it. But here's what I found to be an illuminating moment that he used in the talk, but he used Groovy. I'm going to use Rust, but the idea is pretty much exactly the same. So which of the following is structured? I want you to think about this. I'm going to give you two code Rust snippets, but first let's talk about how returns work in Rust. So in Rust, you can actually return a value without writing return by just dropping the semicolon and leaving it there. So for example, this nut will just return 2, right? So we'll get back to this, but first let's take a look at this code, right? Simply is leap year. It returns a bool, it takes in a year, great. So think about this, take a look at this. I'm gonna move on, but feel free to come back and, think about which one of it, between this and the next example, which one is going to be more structured. This is that same one, minus the else statements, and with one final return at the end, right? So, between this one and this one, I want you to think about which one is more structured, which one's easier to follow the flow of. So I'm going to, wait like 3 seconds. It's a long 3 seconds, but okay. So the answer is the first one, right? This one with the else statements. But why? So let's remove the insides and see what we can tell, right? So we know we're returning a Boolean. So we know that in each of these branches of execution, we do have to have one return. And obviously we know that there is one return. This is fairly clear. We can kind of tell what's going on here, right? Now, if we did the same thing with the other one, we're pretty sure that, at least one of them will have to have a different return statement. But especially, this is a pretty short example. In a larger example, you wouldn't exactly be sure. It's possible that there's a variable that these are all using, or it's possible that something else is happening. It's not easy to infer what the code is doing by simply looking at the higher level structure, right? Like I said, who knows what's going on in there. So we can also test this with the Rust returns, right? So if this will compile in Rust very easily. This is the exact same code as before, just without the return statement and without the semicolon, so it returns implicitly. This will compile, but this won't. And if we take a look at why this won't compile, let's take a look at, what the error Rust gives us is. It's expected, blank, found bool. It says consider using a semicolon, whatever. So it expects this to be blank because it expects that final return statement to be really the only return statement in the code, right? We're going to have one return statement. That's what's implied by the structure. Even the Rust compiler is kind of iffy on, the rest. So it's kind of as far as I want to go for now. I think I'm going to expand on this in another video, but I've already gone over time. So if you're interested, I recommend checking out these references. Especially, they also have their own references, and you can really dive deep on this and go down the rabbit hole if you like. Hopefully this has provided some value, some knowledge, and I'm going to see, I might churn out a couple more of these, but hopefully this one was useful at least.